Good morning. My name is Charlie Baum, and this is going to be our first discussion in our topic on comparative advantage. Today we're going to be talking about production possibilities frontiers. A production possibilities frontier is going to be a curve and a graph, and it's going to show us how much can be produced using resources or inputs. We're going to be looking at a graph with an x-axis and a y-axis, and so these graphs will show us the production possibilities frontiers will show us the maximum amount of two goods that can be produced. Because the production possibilities frontier shows us what is rather than what ought to be, it's a positive tool. It's not a value judgment like a normative tool. Instead, it shows us the way the world is. In the chart on the top of this slide, you can see how many sedans and how many SUVs can be produced by an automaker named Tesla. For example, this chart shows that if Tesla dedicates all of its resources towards producing sedans, it can produce 80 of them, but this would leave no resources with which to produce SUVs. Alternatively, Tesla, according to this chart, could produce 80 SUVs, but this would leave no resources with which to produce sedans. And there are several possibilities in between those two points where Tesla could produce some sedans and could produce some SUVs. For example, Tesla has the ability to use its resources to produce a maximum of 40 sedans or 40 SUVs. In the graph below, you see these points illustrated. For example, point A shows 80 sedans being produced, but no SUVs. Point E shows 80 SUVs being produced, but there's no resources left over with which to produce sedans. And the points in between, points B, C, and D, show points at which some sedans and some SUVs are being produced. Just as another example, at point D, 20 sedans are being produced and 60 SUVs are being produced by Tesla. If you connect these dots, it forms a green line, and this is called the production possibilities frontier. It shows us the maximum amount of two goods that could be produced by a company, and the company in this case is Tesla. Points inside of the green line represent output levels that are inefficient. It's where Tesla is producing a number of SUVs and sedans that is not the maximum number. For example, at point F, 30 sedans are being produced and 10 SUVs, but Tesla could produce more than that, and so point F corresponds to an inefficient outcome where less than the maximum is being produced. Points outside the production possibilities frontier correspond to points that are not possible, points that are unattainable. For example, point G is very nice. It contains 60 sedans and 50 SUVs, but it's unattainable. It's outside of the production possibilities frontier. Tesla doesn't have the resources to get to that point. An opportunity cost is the highest valued alternative that must be given up to engage in an activity. In this context, an opportunity cost of a sedan shows us the number of sedans that must be given up in order to produce one more SUV. For example, if Tesla is producing 80 sedans and 0 SUVs, then it can begin producing 20 SUVs, but it would have to give up 20 sedans in order to do that. This shows us that the opportunity cost of producing 20 SUVs is 20 sedans. If we reduce that, then the opportunity cost of producing a sedan is the opportunity to produce one SUV, and vice versa. The opportunity cost of producing one SUV is one sedan. On this slide, we're looking at a production process that illustrates tanks and automobiles. On the previous slide, the opportunity cost of producing SUVs and sedans was constant. It didn't change along the production possibilities frontier. Here in this graph, we're looking at a production possibilities frontier that's not a straight line, it's a curve, and this shows us that the opportunity cost of producing these goods changes. We believe that the opportunity cost of producing these goods will change because the best resources are allocated to producing each good initially. So that if we go from point A to point B in this graph, 200 additional automobiles can be produced at an opportunity cost of only 50 tanks. That's because we're going to reallocate the resources from producing tanks toward producing automobiles that are best for producing automobiles. But if we continue to produce additional automobiles, moving from point B to point C, then the opportunity cost in terms of tanks will become larger. Here, as we move between points B and C, the opportunity cost of producing 200 additional automobiles is 150 tanks. The opportunity cost has become larger because the resources now that are allocated from producing tanks toward producing automobiles are the resources that are relatively less efficient at producing automobiles. And if we continue this example further, we'll see that the opportunity cost of producing automobiles continues to increase up to a point where 500 automobiles are produced and 0 tanks are produced. We can show economic growth with a production possibilities frontier. At point A, 200 tanks are being produced and 400 automobiles are being produced. With economic growth, more can be produced. So economic growth shifts the production possibilities frontier outward. At point B, 300 tanks and 450 automobiles can be produced. This shows economic growth because more is being produced in this graph with the economy's resources. Economic growth is the ability of the economy to increase the production of goods and services. Economic growth doesn't always affect output equally. In this diagram, we see that economic growth has resulted in more automobiles being produced, but not more tanks. Here there's been some type of technological change that has affected the automobile industry, but the technology has not affected the production of tanks.